In this video, let us solve problems based on tangent to a circle. We've got a question here which reads like this. A point P is 13 centimeters from the center of the circle. That is this. It is exactly 13 centimeters from the center of the circle O. The length of the tangent drawn from P to the circle is 12 centimeters. So here is the tangent which intersects the circle at exactly one point T. That length is 12 centimeters. Now, using these two data, we need to find the radius of the circle. Now, how do you do this? Now, going back to recalling those properties of tangents to a circle, we had this property which said that tangent is perpendicular to the radius of the circle at the point of contact. So the tangent PT is perpendicular to the radius of the circle OT through the point of contact. So here is a right angle, which makes this triangle POT or PTO a right angle triangle. Now, if you've got a right angle here, the side opposite to the right angle is the hypotenuse, which is OP is the hypotenuse and TP is another side. So we have to find the third side, that is the radius of the circle. The length of the radius of the circle is what we have to find. Now, once you've established this, it is very, very, very basic mathematical problem. So all you have to, the whole thing about solving this problem lies on identifying the property to use. That's all. Once you've identified the property, it's very simple. You have to use the Pythagoras theorem to solve this problem, which states that the hypotenuse square, which is OP square, equal to the sum of the square of the other two sides. That is, OP square equals PT square plus OT square. OP square is 13 square equal to PT square is 12 square plus OT square is what you have to find, right? So here it is. So OT square equals 13 square minus 12 square. So OT square equals 169. 13 square is 169 minus 12 square is 144. So OT square equals 169 minus 144 is 25. So if OT square equals 25, OT equals square root of 25. So the square root of 25 is 5. So therefore the length of OT is 5 centimeters. This ends this problem. Let us quickly solve another problem. So here we've got another question which reads like this. Find the length of the tangent drawn from a point whose distance from the center of a circle is 25 centimeters, given that the radius of the circle is 7 centimeters. So now we need to find the length of the tangent which is drawn from a point whose distance from the center of the circle. Now this is the point from where the tangent is drawn, and the distance of this point from the center of the circle is 25 centimeters, and given is the radius of the circle, which is 7 centimeters. So with this data, you need to find the length of the tangent. Again, it's not very different. The tangent is perpendicular to the radius through the point of contact with the radius. So here it is. Here is the perpendicularity. So if this is the right angle, then we've got a right angle triangle PTO, and opposite to the right angle is the hypotenuse. And again, we need to use the Pythagoras theorem to find the length of PT, which is nothing but the hypotenuse square, which is OP in this case. OP square equals PT square plus OT square. We've got OP is 25, so OP square is 25 square, and then we have to find PT, so PT remains PT square. Then OT is 7, so OT square is 7 square. So what we have to find is the length of the tangent, which is PT square. So PT square equals 25 square minus 7 square. So PT square equals 625 minus 7 square is 49. So PT square is 576. So if PT square is 576, PT is square root of 576. So the square root of 576 is nothing but 24. So the length of the tangent is 24 centimeter. So it's as simple as that. A very simple problem. All you have to do is just identify the property to apply in this given criteria, and it's all about simple Pythagoras theorem after that. So I'll see you in the forthcoming videos with more problems based on tangents to circles.